In this video, just wanted to share a quick tip on how you can write some debugging movement code once, use it in any project, on any pawn, and without having to change a single line of code or blueprint nodes inside of your pawn. Now, if you're looking for a more complete solution, I've got actually this VR debug plugin on the marketplace, which is really useful. You can run console commands, do all sorts of things, read blueprint logs, output logs. You can move around. It does all sorts of fancy things that are really useful, like loading maps, for example, and all without having to change anything in your code. It just does it internally. But if you're looking for some very simple code to just move around without having to change your pawn, this is probably the way to go. The reason why you may want to do this, it could be like because you can't change your pawn, maybe it's checked out if you're using perforce for version control by somebody else. You may just don't want to change your pawn at all. Your pawn maybe doesn't have movements in it and it doesn't need it. So this is just a very nice solution for those kind of situations. So if we start by creating an actor, we can call this BP debug move. And the way we can do this is by, instead of going inside of this pawn, which by the way is just a camera with a set tracking origin blueprint node in there, instead of adding like something here, adding some logic in here, what we can do is adding a child actor to this pawn, and then we can make this child actor actually of the class debug move. So we just added basically extra behavior on this actor, but on the map itself, not inside of here, which is really the key. And then if we go inside of here, we can write the logic to actually do stuff with that pawn. Now, if we do get owner here, this doesn't work. It doesn't get the owner for some reason. I don't really know why. I think it should work. But if we do get parent actor, this actually returns what we want. So we can declare this to be a variable of type pawn in case that we need it later, and then we can get the components, some components by class, and we're gonna get the camera component. Then we're going to check for the length, probably making sure that there is at least one item in this, and if there is, then we can actually grab a reference to the camera itself. So let's say get. And then we declare this as a variable. And now we got also the camera to work with, because I want to code some movements basically. But you can really code anything at this point with these two references. It could be rotation, it could be, I don't know, other things that you want to code on the pawn itself. And after that, what we need to do is adding also any enable input, because by default actors don't have inputs enabled. And so we got inputs there, we got the pawn, we got the camera reference. The only thing that you really need to do in a new project, if you're actually migrating these in a new project so that you can reuse it, it's adding some inputs, which is really straightforward. That doesn't seem too much work. We can call this debug forward maybe, and we can call the bottom one debug backward. And then we can say Oculus touch right. Let's say Oculus touch right a button press to go forward, and Oculus touch left X button press to go backwards. Those could be the buttons. And then in here we can say debug forward, and we get that event. And we probably don't want to consume the input. Just make sure you don't do that in case that maybe you want to use also this event somewhere else. So maybe you're using an existing event. One thing you need to make sure is that if you're actually using a key that it's already in use, it wouldn't work. Especially if, for example, we go inside of this pawn here, and if we look at the grab event, it actually consumes the input. So if you were to use the grid button to actually do this, and you have this debug forward bond to the grid button, then it wouldn't work because this is already using the consuming the input, and this guy will get it before the actual child component. So just a heads up there in case you miss it. But if you set it up the way I did with like dedicated keys, it shouldn't be a problem. Now what we can do here, it's all usual stuff. It's stuff that you often do, that I used to do anyway, for moving around. So we can get the pawn, we can get the actor location, then we can get the forward vector here. And if this is up to you, obviously, but what you can do is just leave the forward vector as it is. But because I don't want to be going up and down, I don't care. I'm all on the same level here. If I had some slope, probably I would leave that as it is, so that I can look up and go in that direction. But because I'm moving just on the X and Y axis here, I'm going to make sure that I zero out the Z on that vector, so that I just get the forward direction on the X and Y axis. Then I can multiply this by the distance I want to travel. I'm gonna make it 50. I can promote this, I guess, also to a variable and say move distance. So this is really up to you to actually make these as smart as you want. I'm just showing you what can be done at the very basic. So you could go here, click in here, and I think that if you actually expose these that way, you should be able to see that variable. Maybe let's see. No, it seems you can't. Yeah, you can't really do that. It has to be hard coded. But anyway, that's the move distance in the forward direction. And then we can basically just add these vector to these. So we just move in the direction of the camera where it's looking, but we know the Z. And then we actually get this pawn again and say set actor location. And we set the actor location to this location here. We duplicate these. That's for the backwards. And all we have to do is basically, I'm gonna just literally copy this code. You could make it into a function just not to repeat all these. And all we have to do is probably move this forward a bit, get that, and then we can negate the vector. And this is better probably than having a second variable here, so that you, or maybe multiplying that times -1. It's just, I guess, nice having it like that. But really, all this is doing now, it's basically giving us like movements on this pawn. So I should be able to actually now just hit here, grabbing my controller, and I'm pressing the A button to move forward and the X button to move backwards. I can be looking in different directions and I can move around. So the nice thing about this, again, is that this VR pawn has no logic in it, and that didn't change anything. I just dropped this child component in there. I can get rid of it, and the VR pawn, it's like it was before. This is just for debugging. It gets out of the way, and I can do the same thing with any other pawn, really. So I can do the same thing here. I can get a child component, a child actor component again in there. Select these, drop it in there, hit play. I'm still using the previous one, so that makes no sense, obviously. And I do have the, I believe this is already linked, so this is what I was talking about. I think the teleportation, it's actually using that Oculus A press, so we want to get rid of that just to make sure that it doesn't happen like that. And the Oculus X, but once I've done that, I should be able to basically hit play. So this is actually the, yeah, so this is the standard VR pawn, but now I can move around the same way I was doing with the other one. It's just a very nice way of having some of these debugging code that you use often in different projects. Within a single component, you don't have to do anything. The only thing you have to do, again, to bring it to a different project, it's recreating these guys. So you can give them a name that you always use, like debug forward and backwards. And then before you migrate these into your new project, you just create these two. And then you migrate, and this just works on its own. And you can have all the custom logic to even rotate around and do all sorts of fancy things. So that was it. Hope you enjoyed. Thanks for watching, and bye.